Through the class so far, we've been talking about these three different sets of issues in architecture. We talked about form, the beginning of the class. We talked about physical considerations in the middle section of the class. And we recently finished up this segment on human factors. So the last few lectures here, we're kind of rolling back and saying, how do these things relate to each other? And today in the talk, I'd like for us to focus on, can you merge physical considerations and form? Can you use technology as a source of beauty? And how might those two different aspects of architecture find a relationship with each other? A number of years ago, I co-taught an interdisciplinary class in Plan 2. And I did this for a number of years, but in one particular year, they had 7 faculty members from 7 different disciplines. And they asked for all of us to talk about beauty. So what is beauty in your discipline? How does it work? And then there was meant to be some discussion among all the disciplines to try to figure out, well, what is beauty in a larger sense? And it was a really great group of faculty members that were in this seminar. There was Paul Woodruff, who is a professor of classical philosophy and was Dean of Undergraduate Studies for many years. Betty Sue Flowers, who was in the English department. She taught poetry. At the time, she was director of the LBJ Library and Museum. There's Michael Starbird, a really, really extraordinary mathematics professor. There's a guy named Philip Bobbitt, who was in the law school. He's a constitutional law expert. There was an economist, and there was a cosmologist. That's a guy who studies the cosmos, a scientist, and an architect, me. So those were the 7 faculty members. And the way that worked was on any given, we met once a week on Wednesday evenings, and on any given evening, one of us would make a presentation on what we thought beauty was in our discipline. And then the other panel members would stand up and just make mincemeat out of us, just pick at it and tear us apart and try to see any flaws in our argument. It was great. And it was really, really fun to teach that class. I loved those people and loved that interdisciplinary interaction. Oddly enough, the one presenter who I thought was far and away the best was Philip Bobbitt from the law school. And the presentation he made on beauty was just extraordinary, I thought. And it seemed to fit so well with all of our other disciplines, and in particular, for me, with architecture. So Philip said that what makes beauty in the law is craft. A really beautiful legal argument is well crafted. It is how it's made and put together and assembled. It's well crafted. One might say its technology, its making is sophisticated. So craft was a very big word for him. And around the room, pretty much everybody in their discipline. I mean, Betty Sue Flowers could say, yeah, a really beautifully crafted couplet is amazing in poetry, or a really well-crafted philosophical argument is beautiful in philosophy. So craft seemed to be a resonant word. And then Philip went on to say that craft is then really made up of 3 parts. To have a well-crafted legal argument, first of all, it's very important that there be economy, that it not have fat. It can't be flaccid. It has to be lean and economical. And that makes a really well-crafted legal argument. And again, around the room, the other faculty members, the cosmologist said, Yes, that's what's so beautiful about the universe and about the orbit of the planets, is that everything's in just no more, no less than is required to make it all work in perfect harmony. It's the economy of the system that makes it so beautiful. So that word seemed resonant. And then the second thing he said was that to make a really beautifully crafted legal argument, you have to have complexity. It can't be simple. It can't be a one-liner. It can't be stupid. It has to be rich and nuanced and complex. And again, that word complexity resonated around the room. Betty Sue Flowers said, yeah, in poetry, you need to use every tool in the toolbox. When you choose a word, you choose it for the sound of the word, the meaning of the word, the cadence of the word. All of those things add a level of complexity to the choice of words you put together in a poem. And for a poem to be beautiful, it has to have that complexity of doing all those things at once. So again, that word complexity was resonant. And then the third thing Philip said was that to have a really beautiful, well-crafted legal argument, it has to have potency. It has to make a difference. It has to be extraordinary or awesome or have consequences. And again, that seemed also to be very prominent around the room. Paul Woodruff said, yeah, a philosophical argument doesn't mean anything unless it makes a difference, unless it has an effect on a culture or people's lives, or it makes a difference. So of all the presentations we heard that semester, that notion of beauty as craft and that well-crafted thing depending on economy and complexity and potency, that really stuck with me. And those words are words we use in architecture all the time. We craft architecture, we make architecture. A well-crafted building is certainly something we think of as beauty. And that is technology. How are we putting that building together? And then these other words, economy and complexity and potency, they all seem to work very well in architecture. So as I began to think through that and apply it to buildings, I think you could see that something like a Gothic cathedral, we think of that as an incredibly beautiful building, and people make pilgrimages from all over the world to go see those beautiful Gothic cathedrals. We've talked about them a number of times through the class, especially in the segment on form. But really, honestly, a lot of that form is really about craft. It's about carrying those loads down those groin vaults into those pilasters and colonnettes, and it's really the craft of this building significantly. And it is its economy, just as few moves as necessary that make it work, and its complexity and its potency. Maybe it's easier to see this in other medieval buildings, contemporary buildings with those Gothic cathedrals. This is a little abbey just southeast of Paris, the Abbey of Fontenay. And this is a very simple building in the Abbey. I would make the argument it's a really beautiful vernacular building. But there is nothing to this building but craft. It's just a simple stone wall. When you craft a stone wall, you realize that if you make it thin, it's going to fall over like that. So you have to have pilasters that buttress it up. Those pilasters need to be thicker at the bottom where there's more load than at the top. And all of that is really just about the technology or the craft of making a stone wall. Those openings, carrying those loads around in the arches, we understood that when we're looking at structure and materials, but that's just the way a stone wall and its technology wants to behave. So when we look at that wall, which I think is a beautiful wall, all it is technology. It's just expressing that in the wall. And that happens on the inside of that abbey as well. Those beautiful groin vaults that seem so graceful and wonderful rhythm and very lyrical. But really, it's just those ribs are just there for making those groin vaults. They're the formwork that they build the webs around. And those are then carried via a capital into that column and into the ground. It really is technology that is making those shapes and forms that we look at and say, wow, that's beautiful in the end. And I think you can see that same thing in any era of architecture. And in the case of Le Corbusier, again, someone we've looked at over and over again, when Le Corbusier is working with the technology of concrete, he understands it's this liquid, oozing, fluid mud is what I make concrete out of. And it's rough. And so we get this shape and form and texture that really comes out of the technology of concrete. How you make it, how you assemble it, how you pour it becomes the inspiration for that form. At the very same time as Le Corbusier was doing that, or within a few years, he's doing this building, which is made out of steel. Steel is a completely different kind of technology. And the steel is strong and light and precise, and it can make dramatic cantilevers, and it's amazing in terms of small amount of material to do a big job. And out of that comes shapes and forms and building character that emerges from steel technology. So how technology grows into building form is very much a part of making beauty in Le Corbusier's work. Something like Mies van der Rohe's Farnsworth House that we looked at very, very early in the course is just an absolutely classic case of technology as a source of beauty. It's just a simple steel frame. It has that economy, no more, no less than is required to frame that building. But there also is a complexity, the idea of some of it enclosed and some of it open, the idea of the cantilever versus the span, the idea of it being pulled off the ground. These moments of complexity add to the quality of the craft of that building. And then in the end, it has a real potency, the minimalist quality of it, that strong, single, clear idea is very powerful. The technology is everything that's contributing to the beauty of that building. Now, there is a book that I also got exposed to in teaching that class that I like a whole lot. It's a book by Elaine Scarry called On Beauty and Being Just. And in it, I want to read a little quotation that talks about maybe a contemporary notion of beauty. She says, though the vocabulary of beauty has been banished or driven underground in the humanities for the last 2 decades, it has been openly in play in those fields that aspire to have truth as their object: math, physics, astrophysics, chemistry, biochemistry, where every day in laboratories and seminar rooms, participants speak of problems that are beautiful, approaches that are elegant and simple. So this is a notion that maybe in our own era in particular, we find a beauty in those things that are well crafted, in those things that have an element of truth to them, an element of inevitability to them, and that there's something really quite beautiful about that. So we're going to spend the rest of this talk and a portion of the next talk talking about one architect, a guy named Santiago Calatrava. And he is someone who merged technology and beauty, merged physical considerations and forms to make virtually every building he ever did. He's a very interesting guy with a cool background. He grew up in a fairly wealthy family in Spain, in Valencia, but he grew up during Franco's reign as dictator of Spain. So his family, because that was a socialist government, his family were capitalist, they were not in very good shape during the time he was growing up. When he was 13 years old, there was a little window opened there for allowing people to send their kids out of the country for school. So he was sent to Paris, and in Paris he studied art and was very interested in becoming an artist. He wanted to go on and stay there for college and go to the École des Beaux-Arts. Unfortunately, just at the moment he started enter college in 1968, they had all these riots in Paris, the students protesting, the university shut down, and so he couldn't go to the École des Beaux-Arts. So he goes back to Spain and he decided to study architecture at the University of Valencia, his local university. So he studies architecture, and he thought what he was interested in was art in architecture. But as he studied it more, he became very interested in the engineering side of architecture, the more technology side of architecture. And then he made the decision to go on and get a PhD in engineering, in addition to his architecture degree. So he went to what was the very best engineering school in Europe, the ETH in Zurich in Switzerland. Got 2 PhDs in the end, one in engineering and one in building science. And now he's 32 years old or something, extremely overeducated, but qualified to be both an architect and an engineer. And his work really became this merger of art and technology, this merger of technology as a source of beauty. And I want to start talking about his work by looking at this crazy-ass project that he did when he was still doing his PhD in Zurich. He and some of his friends decided to make this swimming pool structure inside one of the older buildings on the ETH campus. So this building had a dome up above it, and they strung these tension wires from the dome, and between the tension wires they put polyethylene plastic through there, and then they filled it up with water, and they made this donut-shaped swimming pool that was held up by all these myriad of silvery cables that were in tension supporting it. Now, I think even as a student here, this is technology as a source of beauty. It certainly is economy. It's the very least amount of material to make architecture you can imagine. It's just these few cables and some plastic. And so it's got economy. It definitely has complexity. The shapes and forms of all these pieces coming together and crisscrossing and the light moving across them certainly gives a level of complexity. And incredibly potent, the idea of this swimming pool hovering up in space below this dome of an old building. Wow, really, really cool idea. So he is interested in a lot of things, exploring a lot of things about technology and beauty. He has an interest in studying the human body and understanding especially the bones. That's the structure of the human body, and understanding how they work and how joints work. He was very interested in dance, that as kind of the moment when you use your body in an extreme way, all the muscles and all the bones kind of performing at the most extreme. And he began to look at shapes and forms that came out of bones and out of the body moving. And out of that, he began to then make physical objects that had some of those characteristics, like this coffee table. He was also interested in elements in nature. He loved fish, this funny spine they have and bones coming off that, and then the way they can wiggle back and forth different shapes and propel themselves through water that way. He was interested in the way that sort of was like what you could see in botanical elements like leaves. And then he used some of those shapes and forms to generate physical forms as well. And then, when he graduates from school, he starts his practice, but both as an engineer and as an architect in Zurich, where he had gone to school. And he, has no experience, so he's getting rather rudimentary jobs. This first job he got was doing a warehouse, a very mundane kind of building. Many people would say, ugh, gosh, you can't make beauty or architecture out of something as dumb as a warehouse and a limited budget of a warehouse. But he looks at, okay, I've got certain technologies I've got to use here. I've got to make the building out of something. How can I make it beautiful by using the technology of those materials? So he's looking at just the simplest elements, the concrete as it makes certain supports. He's looking at these doors and the way they open up to let trucks go into the warehouse. And he's looking at the skin of the building, just those simplest forms. The concrete as a foundation, and then this metal skin. And he's actually doing two things with that skin. He's corrugating it once, or making ribs in it once, at a small micro scale. And that's, if you use sheet metal, if it's just a sheet of metal, it's floppy and does not have much structural strength. If you corrugate it or put ribs in it, then it does have more strength in one direction. So he's strengthening that material by putting those micro ribs in it. And then he's corrugating it a second time like that, and that strengthens it once again and makes it even stronger. So he's taking this material that doesn't have much strength, he's giving it a particular micro shape and macro shape that gives it much more strength and allows that small amount of material to go a long way. And he gets that with economy and with complexity and with potency. And in many ways, for a simple little warehouse, it's a pretty beautiful wall. There's something really kind of lyrical and wonderful about that little bit of warehouse wall. And he does the same thing with these simple doors. They're just bifold doors that open up. But just by making the joint that bends, dips slightly in the center, when they open up like that, they become really quite lovely, lyrical, beautiful kinds of shapes. But again, just understanding the technology of that bifold door. How does it work? And how can I make something wonderful out of that simple technology? Now, we're going to look at a bunch of buildings by Santiago Calatrava in the next talk. But I just wanted to introduce here this idea that you can take even the simplest idea of technology, even the dumbest kind of material, and if you think of crafting it in a really sophisticated way, if you think of trying to use economy and yet have an element of complexity and seek a real potency out of that, that you can make technology turn into something very, very beautiful. Okay, see you next time.